Okay, so we are testing audio. We will be starting soon. Can we hear any audio there?
Okay, I can hear it on the stage as well.
Yeah.
That's good.
Eugene, do you hear me in the headphones?
Someone needs to. Can you hear it here? Because see, this is the delay.
You don't.
Yo, yo, yo.
Yo. Okay, can you hear yourself?
That we have to look at the display. Muted.
Okay, you should hear me now. Eugene, tell me if you will hear me in the stream. Okay? Boom. Good. Okay, you start.
Hello, everyone. So, good evening. We are here today, PyLadies Munich and PyMunich. Actually, it's been 1 year since we did this meetup, and we're gonna do it again. And I'm here with my name is Liseva Shoa, and I'm here with Anton Caceres, who will tell all the things that we have planned for tonight.
Oh, thank you. Today is a special one. Today is a big one. In fact, the biggest one that we had. We have 3 talks, which is intense. I'm so sorry to put stress on speakers, but that's the format. So we have 3 full talks, and then we have 3 more lightning talks. So we're also streaming this, so we need to kind of keep up to the schedule, right? So people will be watching online right now. Hopefully, say hi if you're watching us online. And we need to be precise on our timing. So that's why don't be offended. Please take seats. Because it's not just us, it's also our online audience. We have 3 full talks, 3 lightning talks. We will make also a raffle of 2 Python books. We will have some interactive session in between. So stay tuned. And yeah, without much introductions, let's just get to the first talk. Or? So, first speaker and our host of today is Rafael. Bravissimo!
Okay, I can hear myself, so this thing is working. I would need someone to put my slide up the front. Yes, perfect. Anton has told me like, oh yeah, we have a lot of talks today and we have to be in time and actually prepare 26 slides for 15 minutes of presentation. And you know that it's 1 minute per slide, so this is not going to work out, but I'm just going to shave a part of the Netlight presentation. So first of all, welcome everyone. I hope you like the office. It's new because we moved here like 2 months ago or so. Maybe you attended the meetup in the like almost 1 year ago actually in the old office. This one is a little bit bigger and a lot nicer decorated, so you can sit around here. I hope you're all comfy. Drinks are in the back. If you need more pizza, I don't know if there's any left, but you know, just feel comfy. If you need anything, feel free to approach me or other Netlighters afterwards. I think we're not wearing stickers or anything, but you know, just feel free to approach me. Just Netlight at a quick glance. We actually are a Swedish tech consultancy coming from Stockholm, where our biggest office is there. With 1,000 Netlighters. Here at Munich, we're only like almost 500, a little bit under 500. But apart from that, in the DACH region, we're like at 11 locations, and we've been around for 24 years. And what we do is mostly software engineering, IT management. You can read the whole rest down there. We also have partnerships with many bigger companies like AWS and Microsoft and GCP and the World Food Program. But I would say let's kick it off with the presentation. So I'm here today to talk to you about Python 3 metaprogramming. The 3 was not in the title before, but I just figured just in case. Like Python 2 is end of life, but you know, just in case, because actually something changed there. But first of all, who am I? My name is Rafael. Just call me Rafa. That's why it's in bold. I'm a consultant at Netlight for 3 and a little bit years now. And I would consider myself a backend generalist with a focus on software engineering. And in my free time, I love playing board games and dancing some salsa. And the topic today is metaprogramming. And basically what this means is more or less a little bit like programs that manipulate or change the way that other programs, I got louder, I think, work. But you might know it, for example, from the Kotlin Gradle DSL, if you're a Java coder. But also like from parsers, interpreters, compilers, or other things. Now, meta obviously is not unique to programming. There's like, maybe you had some model-driven development at university. You have like meta models, so models of models. Or there's also meta humor. So I found this funny thing on the internet. So some genius put this sign up and said like no thumbtacks in wall and fastened the sign with thumbtacks into the wall, right? And then some other smart person put a sticky note that points to the thumbtacks, like, what? Right? And then there's like no sticky notes on signs by putting a sticky note on the sign. And this just continues, right? No sticky notes on sticky notes with a sticky note on the sticky note. And no purple sticky notes with a purple sticky note, right? So you see it's kind of like self-referential and kind of like loopy and stuff. And in Python, the good thing is that everything is an object. So that cuts out some of the work for us already. So you can, for example, get the type of the number 5. And while this would not be a thing like in C or something, in Python you get, oh yeah, this is the type of 5 is a class. It's the int class. And if you get the type of print, I can just throw some functions around, right? And this will say it's a built-in function or method, and it is a class. The type of print is a class. And I can even get the type of none, and it's a none type. And I can also, as I already said, pass functions around. I can throw print around, and I can print. And that's nice, of course, because that allows us to do cool things like decorators. And decorators are the first principle of metaprogramming that I'm going to talk very shortly about, but very, very shortly, because the actual thing that I want to introduce is metaclasses. So decorators wrap functions modifying their behavior, and you might know them from add property, class method, static method, or down here. This is an example from Fast API where you just decorate a function, and if a HTTP GET request arrives, then it gets redirected to this function and it gets executed. And you return a dictionary, but actually some magic happens and it actually gets turned into a string, into a JSON string, right? So all of this is done by this magic decorator. Now, if you're not familiar with decorators, it might be a little bit of a struggle going forward, but let's try. The concept today is metaclasses, and you are familiar with classes, right? So a class instantiates and defines the behavior of an instance of this class. And now we're introducing metaclasses, so classes of classes. And what metaclasses do is they instantiate and define the behavior of a class, right? And this sounds a little bit weird at first, like how is this supposed to look, right? So let's play around a little. We have this class definition here, this class A, but it's just empty, doesn't do anything. We can create an instance of A, and then we can get the type of the instance, right? And it will say this is an instance of A. Simple until here. And we can check that instance is not a class, right? With the handy inspect module that you can import, it's a built-in. And it will say false because A is not this A instance is not a class, it's obviously a class instance. You can also check if A is a class and it will say true. And you can check that the type of A instance, which is A, is a class, which is the same as this line, right? So it's also true. And now I have a question for you. What is the type of A? But that would be tricky to declare, right? You would have to write something like class, and that's strange. But it's a good guess. That's a good guess. The solution is that the type of A is type. That doesn't make a lot of sense, right? And we can check that A is an instance of type. And that also doesn't make a lot of sense, right? We're using type the whole time to query information about our object. And just to check that it's actually the same thing, we can get the type of A and check that this is the type that we're using to query this, and it says true, right? And if we get the type of A, so the type of type, it's also type. I struggled when I was studying up on this, so I can imagine that some of you are confused too. And the solution is that type is actually a built-in metaclass. So we can just call type, and it will warn us. It will give us an error, actually. And it says type takes 1 or 3 arguments. The type that we've been using is this built-in, which is like it returns us information about our type that we're looking for. But if we call type with 3 parameters, actually, it creates a new class. And the 3 parameters in this case are the name, the list of base classes, so what are we inheriting from, and a dictionary with a namespace, so class variables and methods. Right, so this is straight from the Python documentation. I'll explain it. Once the class namespace has been populated by executing the class body, the class object is created by calling metaclass. And this is a little bit like what this talk is about, right? So when we are declaring a class, what is actually happening is that the interpreter is instantiating a metaclass for us. So our class is actually the instance of a higher class. And the hint here is that the metaclass that is referred to here by default is always type, which means that actually we're always, if we don't do any weird stuff like we're going to do later, we're always implicitly calling type. And that means that we can actually have this piece of code, which is like very normal, right? We have a parent class that doesn't do anything. We have some class that inherits from parent class. And with some class variable and a function, we can rewrite this entirely just using type calls to this thing. And you can see that there's some parallels, right? So we say that there's something there, an object that is parent class, and we call type passing the name, the basis, and the attributes. In this case, parent class doesn't inherit from anything and has no class fields or anything. So that's the definition. With some class, it's a little bit trickier. We have to extract this function first, and self in this context doesn't really make sense, but self is just a parameter. It's just a name, so it doesn't really matter. And then we can instantiate in the same way, just that in this case, parent class is the parent class of some class, and we pass in a dictionary the namespace that we have parameter prepared into the dictionary, into the attributes of type. I don't know if I lost someone, but someone is saying, cool. That's cool. I'll just continue. Now, when objects are instantiated, actually behind the hood, two things happen. There's two calls in the parent class of the thing that we're instantiating. So if you're creating an instance, it's in the class. There's a call to new and there's a call to init. And maybe, you have to be familiar with init, but maybe you're not with new. So if you have ever wondered, like, why, if you play around with type hints, why does init never return anything, right? It always, when you type annotate the thing, it returns none, and that doesn't make a lot of sense, right? Because it's a constructor. But the thing is that new is actually the function that returns the class instance, passes that via self to init, and then init initializes it. It just sets some values on the fields. And new usually looks like this, right? It takes the class of which an instance was requested as a first argument, and the remaining arguments is just what you would pass to the class anyways. And the return value should be the new object instance. Now, this also maybe feels a little bit disjointed, but we're gonna put it together in a second. So what actually happens when the interpreter reads something like class A ... is that it implicitly, as we saw before, calls this the meta class, and this is an object instantiation. We're instantiating something because classes are also objects too. Everything in Python is an object. So since this is an object instantiation, it implicitly calls the new function on the meta class and the init function on the meta class. And this looks familiar too, right? It's our name, basis, and attributes. To instantiate this class, not the class instance, it's kind of the meta class instantiates the class, and the class instantiates the class instance. So let's write our own meta classes. So much preparation, and now we can actually do some coding, right? So the use case, please don't judge me for this. It's for didactic purposes. It's stupid, I know, because there's no such thing as private fields in Python and stuff like this, but it's an example. So what we want to do is imagine I write this class model, and for every with a single underscore prefixed class variable, I want to auto-generate a getter for it with magic, right, or meta classes. And it will print it out in a fancy way. So how would we go about this? So the first thing is that we have to say, you might think we can maybe just override the new and init functions of type, right? Because implicitly everything is type, but that is not allowed. You can try that, you'll get an error. So the trick is actually we're going to hook in between. So we're going to create our own meta class, which is just a class, right? And we're going to tell model that please use this meta class, that is our meta class, to instantiate this class. And the way this, the way this works is that we have to tell the interpreter that model meta class is a meta class, and we do that by saying it inherits from type, because if it's a type and type is a meta class, model meta class is a meta class. How do we continue? Now, we saw before that new creates and returns a class instance. So in our case, the instance of our meta class is our model class, right? So this function is going to be called when the interpreter reads this class definition. And what we do is we just write down what we learned before, right? And what we need to do, because new returns a class instance, is we need to instantiate the class here via this type new. And in this case, we're just passing things along, right? In this case, nothing would be changed. This is the default implementation. And now just a bunch of code appeared. But this is not spectacular from this point on, because actually this password thing is passed into the attributes, right? It's part of the dictionary. So you can use all of these fields, parameters, for anything you would like. You can iterate over them, you can change them, you can change the name of the class, you can delete all attributes, you can do whatever you want to. And in this case, I'm just creating a dictionary, I'm iterating over the attributes. I'm filtering some built-in names with the dunder thingy. And if one starts with an underscore, I add this name with the get. There's an underscore in here, remember? And the name of the field. And then I just add this one-liner lambda because it's shorter instead of declaring an internal function. And I wrap this in a nice f string. And then when I actually instantiate my model down here and I get the password, this function magically exists, right? And the only thing that I had to do, or that your consumer, your user had to do, was say this meta class of this model is this model meta class. Cool. Now, why would I do this? The cool thing is that you could say, and you would be right, you can do this in many other ways, right? You have class decorators, you have other things. The cool thing about this is that inheritance preserves metaclasses. So in this case, we have a metaclass here. We can tell because it inherits directly from type. It has an overloaded new. And there's an intermediate class that we define as the metaclass of this intermediate class is this meta. And then we have a final class, which parent class is intermediate. And without writing any other code, when the interpreter runs through this, it is instantiating these classes, right? Using the meta class. So automatically what gets printed because of this line here is intermediate. Remember the name of this class gets passed in here, gets printed here. Intermediate in meta class new. And then when the interpreter runs over this line here, the final one, the same thing happens, final gets passed in here, and the same thing is printed. Coolio. Now, should I even use metaclasses now that we have this piece of information? As I said before, there's other ways of doing things which are more simple. So this is a quote by Tim Peters, the author of The Zen of Python, and he says, metaclasses are deeper magic than 99% of users should ever worry about. If you wonder whether you need them, you don't. So you probably don't need them if you didn't need them until now. But it's good to know, right? It's good to understand how Python works. So the people who actually need them know with certainty that they need them and don't need an explanation about why. Right. And that's my talk. Thanks a lot. There's some takeaways here summarized. Metaclasses instantiate and define the behavior of classes. Type is the built-in default metaclass. Metaclass, this thingy, gets implicitly called when declaring classes. New creates a class instance or metaclass instance. Init initializes it. And there's probably a way to solve your problem that does not involve metaclasses. Thank you very much.
Bravissimo! Bravo, good job.
I did it in the 15 minutes, right?
You did perfect timing, and big thanks for that. So let's switch the equipment. Yeah, we have to sacrifice Q&A to be on schedule this time. We will do ad hoc Q&A. That's when you have a beer, catch Rafael and tell him the truth about metaclasses, why you should use them or not. And yeah, meanwhile, we're setting up our next talk right away. Great, we already have slides here. You can disconnect it. No, this, you can already take it. Okay, it seems like I still have a few seconds to fill in. So we have here also a spatial meetup because we have guests from everywhere. Raise your hand who is not from Munich. Okay, told you. So I don't know about our attendees, but we have some lightning talk speakers that come all the way from London, Vlad there. And we have our team coming all the way from Ukraine. Raise your hands, or stand up actually. You deserve an applause, I think. Big applause for coming just to visit us today. So believe me, sacrificing the Q&A is worth it. We need everybody to speak today. So are we ready here? Okay.
Oh, yeah.
So then Kate, a wonderful pie lady, will tell us about the intellectual property. Please make some warm welcome.
Thank you. Sure. Okay. So I'm very glad to see so many people who are interested in intellectual property rights. Normally this is a very dry topic, and I'll try somehow to break the ice today and to introduce you to a topic which is also very, very important for data scientists, since the topic of big data is becoming bigger and bigger, and we have to deal with a lot of copyrights and also database intellectual property rights. So I'll start with a little introduction on who I am. So currently, I'm assuming the position as a patent engineer in a company dealing with innovation technologies, and I'm responsible for patenting different inventions, mainly in the field of electromobility. And my special field of specialization in IP rights is patents. So patents are mainly granted for technical inventions. So I help our inventors actually to patent their ideas, starting from the drafting of patent applications, also conducting patent searches, and evaluating competitors' patents, monitoring competitors' patents, so that we can detect white spots which we can fill with our own inventions. What actually are intellectual property rights? Why they are so important in the today's world? Those are intangibles which can guarantee a specific marketplace of companies, especially when we speak about startups and medium and small and medium enterprises. Intellectual property rights, they can guarantee you exclusivity when you want to launch a specific product or service on the market, and they will give you also the possibility to protect your ideas and promote, of course, the dissipation of technological knowledge. So you can see that we have a great variety of intellectual property rights. Today, we wouldn't have the time to go through the whole set of IP rights. I will just concentrate on the three main intellectual property rights. Those are the copyrights, patents, and database rights, which have relevance to the realm of data science. As you know, copyrights are very important. Once we create a software, behind this software, there is always a copyright, which will guarantee that this intellectual property will be protected normally for 50 up to 100 years after the creator dies. You have this certainly protected. Copyrights normally protect the creative expression of an idea, but not the idea itself. Patents, as we have already mentioned, those intellectual property rights, which are mainly granted for technical inventions. However, recently there are many there are many changes in introduction of possibilities for patenting also software inventions under specific circumstances, especially when we have a technical application and when we can create a technical effect out of a software on a hardware application. And database rights, those are very interesting IP rights that emerged at the beginning of the 1990s due to the fact that many people who wanted to protect their data, they invested a lot of money in compiling this data. And normally the database rights, they are protected, for example, in Germany under the Copyright Act, for example. And they are typical for Europe and the European jurisdictions. Once you get out of Europe, it's getting a little bit more difficult and depends on the country. So as we know, big data, this is structured, semi-structured, or unstructured information, and it's coming. It's in big volumes. The velocity of generating this data is also increasing over time. And we will have to deal with this data in a proper way so that we can extract some meaning out of it. Data scientists use many different softwares to deal with this data, and they didn't write the software. They do not write it. They just take it, maybe develop it, or develop different derivatives of the software using for free the data online. So this is called open source. The open source is normally void of copyrights, which means you can use the data for free. Programming languages like Python, one very good example of a way to use the open source data. So I'm coming to open source licensing because it actually consists of intellectual property rights which are being transferred from one, for example, software to another. Although you have the term open source, as we said, every piece of software is copyright protected. However, some of the owners of this software can let's say, give the software for free, so you don't have to pay anything and use it just for free and further develop it. The open source licensing, that's why it's becoming very, very common nowadays. And now I want to bring your attention to three types of open source licensing. The first one is public domain licensing. You know that it consists of all creative work which is given to the common public, so it's for free. And afterwards we come to the permissive licensing. This is a very, very special way licenses which is used to attribute to the original authors the copyrights that they.
Just move your slide here.
Okay.
Stand here.
Oh, yeah. Okay, it isn't fine. So permissive licenses allow you to free use a software. You have the right to redistribute it. However, you need to copy the copyright text inside the new version of the software, which means if I take a software and I further develop it, I have to make sure that the copyrights are inside of it, of the original software. So it's a way of passing the copyrights to the newer version of softwares or the derivatives of the software, so that these copyrights actually are attributed to the original owner of the software on which you based your further developments. So the last type of licenses which I was complement on, this is the copyleft licenses. Those something like permissive licenses. However, they are a little bit more stringent, which means once I take a software here, not only I need to copy the original copyright text into the new software or derivative of software, but I also need to assure that the new version of the software complies with that what's written inside the copyright license, which means if I take the code, the derivative of the code or the alternation of the code, the new code should comply with the original intellectual property rights. Or I have written, if you modify the code, it has to be exactly as open as the original one. So here I just took some statistics, how often permissive licenses will be used. In most of the cases, we have between 65 and 75% of the open softwares that use permissive licenses. This means you copy and paste the copyright text and licenses inside your new version of software, and that's how you guarantee that the original owner is being attributed the needed respect for his intellectual property work. So now I'm coming slowly to the topic of software patenting. Copyright only protects, as we said, the literal expression of a computer program, not the idea behind. So many companies are just trying to also protect the idea behind, and opposite to the open source, of course, they want to get patents on this. However, the European Patent Convention is organized around the exclusion of patentability of mathematical models, as well as schemes, rules, and methods for performing mental acts. So having a software which has a lot of mathematical algorithms and models would be difficult to be patented. So why it's difficult to get a software patent? First of all, software patents are very interpretable. And sometimes courts just kind of fight over what is the technical effect being produced by a software. So they need to define actually how technical the software is. Is there any kind of real improvement in the real world of a specific product based on a software application or not? And if yes, in how far? So since we have also very rapid technological changes in the innovations, these software patents, they are getting very fast out of, let's say, relevance, and their value decrease. Normally, you need between 3 and 5 years to get patent at the European Patent Office. So once you take the patent in 5 years, maybe the software solution is not going to be of any value anymore, and it will be obsolete, more or less. So, before you make the decision to file a patent on a software, maybe it will make sense to, as I said even before, have a look at the different other ways of protecting your intellectual property rights, namely keeping your software, let's say, idea a trade secret, because once you have a patent, you need to disclose the information in a way which is reproducible, which means everybody can reproduce it based on the patent that you have filed. So this disclosure in many cases is not desirable because it allows many companies to reverse engineer what your idea is. So maybe you can keep the trade secret, and then you have the database rights, as I said. In Europe, it's called a sui generis. This is a special protection of its own kind, as I mentioned. It has a validity of 15 years. And once you compile the database, you can protect it under this copyright, similar intellectual property right. And the last one is the copyrights. As we said, softwares are always copyrighted. So now I'm directing your attention to the topic of neural networks, because as you know, many of those neural networks will be used in artificial intelligence. Special algorithms will be developed in order to tap into the data, which is in the also in the big data across database systems. So normally machine learning algorithms are, as we said, mathematical models, which means by law, by the European Patent Convention, they will be automatically excluded by patentability. So we have this exemption from protection. However, applied to certain problem, an algorithm may become part of a patent, as we said. And here I will give you one example, which is of Google. They managed to patent an algorithm, which is a neural network. And I extracted the first claim of this algorithm, where you can see that this algorithm was a hardware integrated circuit. So this is a software solution which was integrated on a hardware, which gave the possibility of Google to get a patent on this. Should that not be easily applicable on hardware inventions or existing products, hardware products, it would be far more difficult to get a patent on that. So you see under the number 300, there's a compute system which uses different operated compute units. This is the max. And in this 102, this is the first memory storage system. You store non-zero data, which will be generated by the max. So this is a patent which was granted recently, I think on the 14th of November this year. So to wrap up, as we said, IP rights are intangible assets of companies which could guarantee exclusivity by specific products and services, and inventions, brands, different other kinds of intellectual property protection rights. As we say, open source software, they renounce the copyrights, they give you the opportunity to develop and a different version or derivative of softwares and reproduce it without the need to comply with any IP rights, apart from, of course, the copyrights that we mentioned. In most cases, artificial intelligence software is protected by copyrights in general. And as we said, it's very difficult to get a software patent and to enforce it in many cases, because in order to enforce it, you have to prove that somebody stole your software idea and implemented it somewhere, which is very difficult to implement. I have in my area, for example, e-mobility, hardware patents, which are difficult to prove of infringement normally, so software will be even more difficult. So actually, that's it. If you have any questions, please feel free to contact me, even afterwards, after our discussion session. So thank you. Well,
very good. Thank you.
Yeah.
Thank you. So before we go to the break, we have a little present for you. Now, while preparing it, need another 5 minutes or so to do that. Meanwhile, our meetup is growing a lot. So I'm wondering how many people are here. This really will take some time to count. Maybe you can just help me out really. 1, say it loud, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's do first here. 10, 11, 16, 17, 18, 19, 20, shit, counting, difficult. 21, 22, 23, 24, 27, 28. 4, 5, 7, 8. It's over 100. Damn. Is preparing these meetups. Really, when we were below 50 people, it's easy to find a host. At this size, really hosting 100 people, not every company can. So if you, by whatever reason, to me or to Lisa, because this is a limit that we reach now, it's really difficult to find a big space in Munich. Yeah, we know Munich, complicated. And for January, we have one, but we do need speakers. So if you have a good topic, then please talk to us as well. You ready? Okay, do we need your screen share again back? Okay, do that. Oh, infinite. Okay, I have a raffle for you and Lisa will tell you how it works.
So hello everyone. So today we're gonna play this game on Kahoot. So I would say just come here and scan the QR code or enter. You don't need to the application. You don't need it. Just do that. Yes. Bring it. So we have some books today to give it to you. One is this book, great book from Fluent Python. It's from Luciano Ramalho, the second edition. And we have also here.
Of you, I would say. So
Yes.
blessed by Luciano.
Blessed by him. He's always cooperating with us. And yeah, he's a great Brazilian writer. Very good. And this other one is the Architecture Patterns with Python, which is also a quite great book. So let's see. I just need 1 moment. I will put it back. Wait. I will put it back. Don't worry. Share the screen. It's always hard to share the screen. But okay, now I think it would be bigger for you to see. So yeah, how many people we have it here? Let's see. Please put some name in that we can identify you somehow. So we have around 82 people. But yeah, for this game, you don't need to know Python actually. So if you are willing to learn, this is the chance to get booked for it. And we're gonna just try to answer with our best. I also don't know the answers, so don't worry if you don't know. But the thing is, you have to be fast. And there were people here who are very fast, right? And maybe this time they will get more things or something. So let's see. It could be challenging. It could be easy. Well, you have some 25% of chance. So we are around 83 and I don't see so many people waiting for. So I think we can start soon. Let's chance. Start lowering. Oh my God. He doesn't have internet. Someone share. Okay. Did you get it? Did it work? You started with the wrong internet provider. Yes. Maybe you can ask someone from your side. Yeah, we are 88, so some people are still entering. Who else? Who else? Let's hit the hundreds. So 89. Let's see. Let's see. Where is? Okay, maybe with 90 I should stop. Okay, what do you think? Yes. So one more person. Enter. It's not happening. I think I will enter and then I can start it. Someone help me. It's leaving. It's the connection, I think. So, okay, we're going to start it. Sorry. 87. Yeah, otherwise I will lose people. So we're going to start it now. So let's see what's about. So scientific factors, because of today meetup is very scientific related. I thought maybe we can have scientific facts about Christmas. So which scientists introduced Christmas tree lights to the public in 1880? Ah, okay. Please remove it. Okay, good. 50, 58, 60, 64. Oh my God, you have 1 second. It's Edward Johnson. A lot of people thought it was Nikola Tesla. I also thought. So not bad. Who is Winnie? Freddy and F. Whatever F means. So let's go to the next. Before electric lights were strung on Christmas tree, what did people use to illuminate them? Animals, I don't know. So players type your answer. Oh, this is hard. This is the killer. So a lot of people would just die in this one. So keep playing. So probability is that very few will get it right. So let's see. I'm curious. Is it case sensitive? Is also I'm thinking. That would be me. But let's see. You have 3 seconds. You need to type fast. But almost everyone answer. Oh my God. Candles, fire. Candles. Okay, even if you type it wrong, I think there is some magical search here. So you're lucky. Candle, great. Makes sense, right? There is no electricity. So Freddy is still on top. I don't know who is Freddy. But anything can happen. And Uella was doing very good in some meetups before, so maybe she will catch you. Christmas light would tangle due to entropy. Billions of ways to tangle, only way to fix. Is this a joke? True or false? Wow, 50. You need to be fast and you need to be right, okay? So it's not only you are right, because it will account for the speed. 85. But everyone is trying. There is 50% chance. So, ooh, true. Let's see. Freddy. If Freddy is close to you, maybe you. What scientific fact would argue that Santa's reindeer are all female? Oh, this is interesting. Their fur is brown. They still have the ants. I think it could be related to fur, but I don't want to influence you. Their tails have a white patch on them. They work in pairs. I think it's interesting. I don't know. Females work in pairs, apparently. It's weird. Okay, 5, 4, 3. Answer. Just try. Yeah. Okay, they still have the antlers in the later December. So that's how they know that probably they were females. Oh, Freddy. DT. I think it's a company. Oh, let's see. True or false? Most reindeer are buoyant and can float in the water. Guys, I don't know English so well. I would get it wrong. What buoyant means? Floating. Okay. Floatable. Floating water. Okay. I mean, floating or swimming. Okay. Let's see. I trust you. Half of the people thought it's okay. Half got wrong, half got right. Freddy. But we have 2 books, so the second person will also get a book. Let's go to the next one. Which of the following statements about reindeer is false? They really like this animal, right? Some can have red nose. They can float in water. Males shed their antlers in winter. They cannot see well at night. I also cannot see well. I think only cats can see well. Yeah, let's see. 65, 68. Ooh, this was so fast that you answer before the time. I'm very proud of you. But yeah, they cannot see well at night. You see? Could be that I'm a reindeer. Eugenie, you are playing. Oyada, Paul, Freddy, and Al. Okay, it's you see, you still can win because those people they just get out of the podium. So, which NASA Apollo mission first confirmed that is a Santa Claus? They confirmed this? No, kidding. They were kidding. They are considering aliens, Santa Claus, and everything else. It's not possible. But yeah, it looks like it's Apollo is the right first word. This was hard. This was hard. I agree. But let's see. Okay, Munich, it's coming. Let's go to the next. In which direction should Santa travel from the international deadline to not lose any time? I don't want to question this. Maybe he should not take some train, I think. Let's see, 60, north, south, east, west. Who is good in geography? Ooh, west. Great. This was Eugenie now is really leading. Munich is also leading. Let's see. Given the 2.2 billion children on Earth, about how far does Santa have to travel Christmas Eve? Oh my God, the speed of light. Let's see. Calculate very fast. You have 10 seconds. So what do you think? If Santa would visit all the children, it would be amazing, right? That all children would get something nice in Christmas. That would be amazing. 80, okay, 150. Wow, a lot. Yeah, miles, but okay, they put in kilometers, you have some idea. Okay, me? Okay. Alina is also almost there. You have 2 more questions. According to physics, about how fast must Santa sleigh travel on Christmas Eve? Wow. Wait. Let's take a look on these numbers. So what do you think? Answer. 8, 7, 6. You have few seconds. Don't give up. If you didn't show up, you don't know. Maybe now it's your time. This one is hard. So you see, it's some people are sad. So I think things are changing. Me is winning. Let's go. Who invented the idea of Christmas cards? I thought, yeah, who did it? I think a European person, I guess. Richard Draw, Thomas Edison, Robert May, Henry Kohler. Okay, this is the last question, so we're gonna see who we're gonna get this prize. I will give the first one for the first winner this one. And the second winner this one. Are you all? Who it is? Let's see. Me. Ooh! And Sophia. Ooh! Oh my God! I guess Pi Ladies won it. I didn't give the answer to them. Come here. So, me, right? Yes, come here. Make a photo. Woo! Come here. How is the photo? Come here. Let's take photo together.
I take pictures with you all of them. Okay, come on. One more. Good. We have it.
Woohoo!
So,
Congratulations.
So what do you say? Should we let people have their break now?
Yes, now you can have a break. You are exhausted of working on Christmas quiz.
but we have 5 more talks, but they are short.
Short, lightning talk, yes,
Short
yes.
and fun. So please help yourself, get some beer, and let's play some music.
Woohoo!
And it's time to continue, finally. I would kindly ask you to be quiet because we have the next session now. We have one more. Oh, let's mute here. We have one more like big talk, and we will have 3 lightning talks, and all are fun. Believe it or not, all are fun. We will be quick, and maybe we will also stay for as long as Netlight is not kicking us out and make here a party. Open the doors to the crowds, finish their beer. Let's see how this ends. So for now, please, I would need a big round of applause for Andrey.
Is it better? Yeah, fine.
We need to turn on this one. Does it work? Try it. Oh,
I'm trying. Yeah,
good.
works.
all right, go for it.
Awesome. Yeah. Hi, everyone. Super excited to be here today and talk about LLMs for a change. I'm working with DStack, which is an open source tool for running Gen AI models in the cloud. But the topic of today's presentation is not DStack, but open source LLMs and how to use them in production. And before I begin, quick question about like how many of you are doing anything with LLMs, open source LLMs, or all right? Yeah, quite a few. And also curious about LLMs, thinking of doing something with them in the short-term future. All right, it's always difficult to find the right balance between beginner level and more advanced. So I'm aiming for some middle common ground here. So if you don't know anything about LLMs, bear with me. But still, if you are an expert in LLMs, I'm not going to go into like great depth here, but let's see how it goes. So first of all, basically LLM, you can think of it as ChatGPT. And how many of you using or used ChatGPT? So you already have some understanding of what an LLM is and how it works. So, but today we are going to talk about open source LLM. So what is the difference? ChatGPT is powered by GPT, 2 different versions of GPT by OpenAI, and there's also such a thing as open source LLMs, basically LLMs that built by the community and they come with an open source license, means that you can use them for free, means that you can fine tune them and you can deploy them. And today we're going to talk about why to do that, how this can be done, and all of that. So the first thing is why open source LLMs anyway. So given that we have already OpenAI and ChatGPT, why bother and why open source really matter? So a couple of things. Number one, if you watch this drama recently about this OpenAI at all, some users were worried about whether they business is going to stay in the market, because all of the APIs depend on a proprietary LLM, and that's the problem. If your application depends on proprietary model which you cannot control, and you barely know if this model may change overnight, and everything might stop working. That's one of the reasons to use open source LLMs, where you always know what version is deployed and you have entire control of that. And you can also do different tests and see if this model works. You can do different deployment and then roll back at any time. Second important thing is customization. That's the best part. Open source LLMs are all about community. Means that if somebody releases an open source LLMs, means that everyone can build on top of that LLM. You can deploy this LLM, or you can build on top of this LLM and fine tune it to solve some specific problem and then share this result of yours with everyone else in the community as well. So then privacy, of course, it's a big topic right now. A lot of companies are exploring what it means basically in terms of privacy to use proprietary model and how safe it is. And open source LLMs give you a great control over this because you control everything, the data that is used to train the model, and also the data that is fed into the model. And finally, costs. Cost is a big topic. And if you used OpenAI's model, you might know that the large model might be expensive, especially if you use it a lot in your applications. Your bill may be really high, so you might need to pay a lot. On the other hand, the OpenAI also has this cheaper model called GPT 3.5, which is a lot easier to use. However, in case you do plan to use the LLM very heavily, it might make a lot of sense to use a much smaller model and host it yourself. And that's why open source LLMs can come to rescue. So by no chance I aim to mention every major open source release in this talk, but I'll mention a few most important releases here. Again, if you are into this topic, you already know, but if open source LLMs is something that you'd like to explore, start with these three. So Llama 2, this is a model released a couple of months ago by Meta, and it is offered in partnership with Microsoft. This is one of their best quality-wise models, and it comes with different sizes: 7 billion parameters, 13 billion parameters, and 70 billion parameters. Again, if you don't know anything about what parameters are, you can think of this as the size of the model, and we'll talk more about what size really means. Well, the smaller model is cheap. It is cheaper to use it in production, less hardware. You need to host it, and etc. So Llama 2 is a very general model. It gives you a very good quality, and it has open source license, which means that you can use it commercially for free. Right. Another model which worth to mention is Code Llama. This is also a model by Meta, but it is a fine-tuned version of Llama 2, where they fine-tune it on solving code generation tasks. So it is very good at very specific thing, generating code. So why it is very important? When you talk to, let's say, ChatGPT, you might ask it questions. You can ask the model to do something, and then you basically operate with the communicate with the model. However, an LLM can not only generate native natural language, but it also may generate computer language, like, for example, take JSON or take SQL. And this is a very powerful use case, because then you can make LLM to act on your behalf and automate stuff. So, for example, one very quick example is you can ask an LLM a question, and an LLM can give you an answer in the form of SQL query, and then it can automatically run this SQL query and get you data which you ask it for. So, or another example is use LLMs to automate stuff. And finally, Mistral. This is a more recent model, and as you see, it's offered only in one size, very small size. It's built by Mistral AI, and what makes it also this model, this just like Llama 2 and Code Llama, they are all commercially, can be used commercially. And also Mistral is very customizable, but we'll talk about it too. So Llama 2 70B at glance. So this is the largest version of Llama 2. On the left-hand side, you see a lot of benchmarks. A benchmark is something that you use in order to tell how good the quality of the model is. So for example, the first one is the most popular one. It's massive multitask language understanding. It rates how model good at pretty wide range of different tasks. And here you can see how Llama 2 compares to GPT 3.5, GPT-4, and some other models. So this data comes from the original Llama 2 paper. But what is basically worth your attention here is that Llama 2, you can see that at some of their benchmarks, it comes really close to GPT 3.5. So it means that it's comparable in terms of the quality, but it also lags behind in terms of quality compared to GPT-4. So it gives you a feeling how good the open source models are in terms of the quality. Also, a quick note on Mistral 7B, why this model is worth attention. Basically, the data on different benchmarks shows that it beats not only other models of the same size, but it also beats twice as large models. So basically, it beats Llama 2 13 billion parameters. And then it also matches the performance and some tasks, the Llama 1 34 billion parameters. So this is a pretty powerful small model. And in terms of model size, you may wonder, okay, so how do these open source LLMs compare to ChatGPT, which is using GPT-4 and GPT 3.5? So yeah, you can see, well, you cannot see, but basically because of the color. Here's a very large circle. Sorry about the colors. Which shows you the size of GPT-4. And then, well, basically, GPT 3.5 is a lot smaller one. And then you can see that Llama 2 is almost like three times smaller. And this slide is really bad, but Mistral is not seen here because you see the video here. But think of it as a dot basically. It's if you compare Mistral to GPT-4, it's just a dot. But still, it's interesting to see that that even using even smaller model, you can achieve you can achieve the quality that matched of GPT-4 or exceed it, and we'll see how it works. So here's the data from their study by Snowflake that shows how you can leverage a small model for solving very specific tasks. So what they did, they collected a data set for code generation and basically generates in SQL queries. And then they fine-tuned that model. And then they compared how this fine-tuned model match their quality of larger models. So they compare it with two other models of much greater size. And what you see here, that basically the fine-tuned version of the small model actually matches. And it matches not only these larger models, but it also comes quite close to GPT-4. So the takeaway here is that if you fine-tune a small model right way, it can actually come really close in terms of the quality to GPT-4. Again, this is just a single study, and there are many others. And as we speak, there's ongoing progress here. So there are new models appear. So we can expect that smaller models will rival basically their GPT-4 as a in terms of ease of use and costs and also control. So here's another example of how you can take an open source LLM and fine tune it, and how it might compare to GPT-4. So here we see two other models: Wizard Coder, 34 billion parameters, and Find version 2. Of similar size. And basically, there are lots of benchmarks. You're not familiar with But what is important here is basically look at the first line, human eval. Human eval is a benchmark that is used to measure score how great an LLM at solving coding problems. So you can see that Find and Wizard Coder actually come really close to GPT-4. And there was a funny story when these models actually were released. They actually bit the quality of GPT-4, and within a week, OpenAI updated their model to catch up, and basically they are again the first number one in their leaderboard. So now we're going to talk a bit more about how actually to use what it means to use open source LLMs. Right. LLMs are very heavy when it comes to using these models for fine-tuning or deployment. So here this is the slide from some application that calculates how much memory you need for serving or for training for an open source model. So here we have this Llama 2, 70 billion parameters. And if we take it in the original precision, this is another thing to know. Basically, an LLM is just a set of weights, basically numbers, float point numbers. So there are so many float point numbers that we have 70 billion parameters. And in order to use this model, we would need 256 gigabytes of GPU memory. Means that it doesn't even fit into any known GPU, which makes it might make you wonder how to use this model at all. And if you decide to fine-tune this model, basically to train this model, then it would require 1 terabyte of GPU memory, which means that, well, it's really hard to fit it into one single GPU, which means that you're going to use multiple GPUs in order to train this model. But we'll talk about optimization techniques in their further slides. So here we have some data that gives you an idea of what it means in terms of latency and cost to use an open source LLM for deployment. Lots of numbers, but let me walk you through this table. So on the left hand side, you see different models. 7 billion parameters, 13 billion parameters, and the largest Llama, 70 billion parameters. And then this study is by Hugging Face. What they basically did, they took the corresponding GPU that matched their requirement, and then they calculated what it costs to per hour, and also to generate 1 million tokens. So if you use the smallest Llama model for generating 1 million tokens, you would pay basically $32, which is pretty expensive. And if you are using the largest model, then you would pay $500. And here we're using the largest AWS instance that they can offer. It's 8 GPUs, 8100, 80 gigabytes each. So it's the largest instance AWS has. Right, so it's still pretty expensive. And also you see there, you see the latency numbers here. And latency is something that you would probably worry a lot when you deploy a model, because in the end, it's all about performance. Here we only have one concurrent request here. And if we're using the largest model and we're using the largest instance GPU AWS actually offers, then we're gonna end up having 41 millisecond per token, which is still okay, but you can see that it's really hard to use a model without any optimization techniques. So that's why here comes the first optimization techniques, known as quantization. As I told you, a model is a set of weights, basically float point numbers. And in order to use it for training or for inference, we have to load this into memory, GPU memory. FP16, this is also known as half precision. It's not the full precision, but not float point 32, but float point 16. So a lot of models actually use this this half precision. So it's really difficult to fit it into the memory. So if you'd like to reduce significantly the amount of memory needed for using this model, you might consider using quantization. And this works this way. Instead of using float point 16, we're using, let's say, int 8. And we are using this quantization to transform with losing some precision, some quality. We reduce the amount of weights. But this technique is super powerful, and it shows that if well, with a lot of most of the research is showing that you can use it without the loss of their quality. Use it pretty much. Int 8. But also you can consider going even lower precision, and you can consider using int 4, int 2, and maybe even lower. But that's another topic to discuss. And here's another calculator screenshot that shows how the memory requirements changes if you are going lower precision. So the same model, Llama 2 70 billion quantized, with so half precision, we basically divide by 2 the amount of memory. Still don't fit, we still cannot fit into one single GPU, but then we use int 8, and now we can actually start to be able to use one GPU with this model, but then we can go lower. And then on the very right, you also see how the requirement for training changes. But you still see that even with the lowest precision, you cannot use it for training, right? Here's an updated slide, which you've seen before, which shows latency and cost. But now with quantized technique, you can look at the right-hand side that we basically saved a lot of money. Basically, the cost drops 10 times. And it's a lot easier to use it with even smaller instances that AWS, for example, provides. Right. What about training? So here you can see that training is still very expensive, and you need a lot of GPU. So for the rescue, we can use this technique called LoRa, or also known as low rank adaptation. So how this techniques works in a, let me briefly explain. So if you imagine the weight of the model, basically this float point numbers, weights, which are very difficult to fit into the GPU memory in order to train, we do an optimization here. We take only a smaller subset of all these weights, and we call it an adapter. And then we train this adapter, lower rank adapter, instead of training the entire set of weights. And once we've trained it, then we merge this lower subset of weights called adapter with the original model. And then we get a trained model, but instead of fitting everything into the memory, we only put in the subset of it. Again, there's a paper if you'd like to know better how to use it, but that's one of the most foundational technique here for LLMs, which allows to train large language models without, again, a very significant loss of quality. And here's one more table that shows how, if you take, for example, Falcon is another open source model, and you take, it's probably the largest open source model not known today, and it shows how the requirements drop if you are using LoRa, and then you also combine it with quantization. So the third line here, it's called QLoRa. It means it combination of quantization with LoRa. So you combine two techniques here, and you can see that basically you drop the memory requirements like ridiculous amount. Ridiculously, it's like more than 30 times. Right. So how powerful fine-tuning really is. So again, how many of you are familiar with what fine-tuning word means? If you can raise your hands. So fine-tuning is basically you take a base model already trained by someone, and then you do an additional step of training, but you are using some other data set that you want to use to tailor the model for. For example, we have a general model that can do everything, and then we take a code generation subset, and then we like post-train or fine-tune the model on this subset to make sure that this model is specialized in this particular thing. So that's no idea. I like bears. Some LLM interfering into the talk, which likes bears. So how powerful fine-tuning is? We already know that it can be super expensive, and it can be super heavy in terms of memory and time-wise. But here's another study by Anyscale, now another company, that they took the smallest llama 2, and then they used two different ways to fine-tune it. Basically LoRa and the standard one, basically to compare how powerful the LoRa technique is. And then they compared it also with a fine-tuned version of larger models. And they took three different problems. One is functional representation. The first one is it's when you take an unstructured data and then you ask an LLM to provide you structured data. So for example, you take a scan of invoice and tell, okay, so give me the data from this invoice in structured form, like who's this invoice from, like what is the amount at all. Second is SQL generation, and third one is solving math problems. And what we see here is that basically on the first two sets of problems, we see that LoRa fine-tuning technique, it matched actually the quality of the standard technique. And then what it really means is that we can take the smallest model and we can apply these techniques for fine-tuning, and the resulting model can match the quality of much larger models trained without this optimization technique. Means that it's super efficient and it's super cost effective. So you might find it scary, like too many things here, and I'll try to simplify this. So basically, if we'd like to fine-tune a model, there are different ways to fine-tune a model. The simplest way is called supervised fine-tuning. You basically create a special data set of that looks exactly, for example, to give you an example, if you ask an LLM to provide you, I don't know, a poem, then we can, for example, have a lot of different poems and feed them into the LLM, and an LLM will learn through these examples how to generate poems. This is called supervised fine-tuning. You only need to bring some additional high-quality data. But then it's not the only way, and there are more powerful way, and I'm afraid that we're not going to have time to cover them all. But I'd like to just mention that there are other ways. Like one way is most complex and most efficient, called reinforcement learning human feedback, RLHF. Again, if you dive into LLMs, you'll learn about it, and then when you'll learn more how it works, it's not going to look really complex at all. All you need to do to use this is not only provide the data set, but also provide additional ranking. This piece of this, for example, poem is good. This poem is not good. So you are not only showing poems to your model, but you also tell which poems are good and which poems are bad. So basically, you provide feedback. This is the main thing. Well, I'll probably conclude because we are probably going too deep here. Again, if you decide to go deeper, there is also alternative, much simpler alternative to LLMs, which is pretty effective. And again, if you'd like to go even deeper, there are other things that might be super efficient when it comes to basically deploying the LLMs. I'll be sharing slides anyway, so I'll share them later. So if someone is interested, you'll find about this. Yeah, I guess that's all.
Beautiful. Big applause. Lovely, lovely. All right, we still have the most fun part of this meetup, lightning talks. Those who don't know, lightning talk is a format when we have just 5 minutes maximum for a speaker to present something, and we have maybe even one extra slot if we are on time. So if anybody will spontaneously want to present something about Python, you're very welcome to do so. Please, Lisa is the first with a talk, announcement, I don't know. Let's put her slides here. We also take the fast microphone. Boom. Are you sharing?
Yeah, let's see.
Okay, now you are. All
Hello,
right.
hello. So this is very short lightning talk, really short, really lightning. So one question: do you like bears? Yes, no, depends. Yes, who say yes? Okay, who say no? I think you know already what I'm talking. Depends. Okay, some people say depends. So depends, right? Maybe you like this kind of bear, the teddy bear. Maybe you are scared of this kind of bear. I want to know if you like this kind of bear. So there will be an event next year. It's called PyCon DE and PyData happening in Berlin, a city where you can hunt bears in a nice way because they are status. And we have some tickets to give for PyLadies. So here actually it doesn't show up so well, but okay. So if you are PyLadies Munich, this is a QR code where you have the chance to apply for a ticket. We have decided this year we're going to run a process to grant some tickets for the community, for the people who need or for people who knows, but apply it anyway, and we will consider you as an applicant. So this is the QR code. I will add in the PyLadies Munich later if you don't get it here. But yeah, I would love to see you there and take a lot of people from PyLadies Munich to Berlin next year.
All right.
That's it. Thank you.
Thank you. Lisa, how do we increase the chances? How the person can get better chances?
So if you really need a ticket, please apply. And if you don't need, apply too. Who knows? But we will try to give it to the people who need. So if you're a student, and yeah, we all have been there, and it would be nice to give to someone who can join.
Is it 100% fair, or is there some?
It is fair. It will be fair. I'm a fair person.
All right, very good. Thanks to PyLadies then. Yes. Okay. You girls are ready. Boom. Yeah. You hold this. Okay, we need a presentation. You're sharing it, yes? You need to Wi-Fi. It's okay, don't worry. Okay, we need this. I'm reminding you that these girls, and there are two more, there and there, who traveled from Ukraine to just visit us here. So I think that's cool, and it deserves yet another applause. And at the end of this talk, I'm sure I will ask you again for applause, because that's just the way it is. So we need... Good. Thank you very much. So something went wrong here, but we will do it again now. Okay. Do this whole thing mute. Yeah. Okay, now present. Very good. Yes, that should work. Okay, do we have it now? Very good. I think that this is also a good point to ask you for applause for Mr. Eugen over there, who is doing the whole streaming thing. All right. Here you go, please.
Hello, everyone. My name is Alina.
Hi, I'm Valeria.
And we're so excited to be here at PyMunich and PyLadies Christmas Meetup. So, we're new at Tech 5, and being part of this event is truly meaningful for us. So, today we'd like to talk about dealing with self doubt in the tech industry.
I've been working in tech industry for more than 2 years, and from first days I work in here, I have doubts. Am I working good? Am I working well? And I know in this room, many of you may feel the same, may have doubts about their knowledge, their skills. So, Alina, could you say us if it's okay to feel what we feel?
Of course, it's perfectly okay to feel doubts about your skills and abilities, even after many years of experience. And these feelings often come together under the term imposter syndrome. Well, it's important to recognize this syndrome in yourself, as it can have a negative impact on your career and mental health. Well, here are some signs to look for. Well, you feel like you don't deserve your success. You worry that you are going to be exposed as a fraud. You were taking on challenges and opportunities for fear of failure. You have difficulty accepting compliments and compare yourself to others and feel inferior. And now let's explore the underlying causes of these feelings. Well, Valeria, please share your insights.
But before I tell you the reasons why you can feel imposter syndrome, I would to emphasize that it's possible to cope with particular problem you have with your imposter syndrome. You just need to recognize your problem, and then we can suggest a possible way to control it. So it's doable, believe us. So why you can feel imposter syndrome? Maybe you're a perfectionist. You're concentrated not just doing your job, but doing your job perfectly. You compare your results with someone else, and you associate your self-worth with your quality of your job. But these things are not equal.
While if you are a perfectionist, it can be helpful to learn to love the process and not only the end goal, to celebrate small wins and not hold off for the big ones only. Understand that making mistakes are the only way to learn effectively and concentrate on your successes, not your failures.
So maybe you frequently feel exhausted because you're a superhuman. You work even you don't have to, and you just want to hide your doubts about quality or quantity of your job.
If you find yourself overworking day after day, it's important to set boundaries and recognize the benefit of rest. By prioritizing the task with the greatest impact, you can maintain the healthier work-life balance.
Yeah, here's another type of people, self reliant. They never ask for help because they are afraid to be perceived as a fraud. But the main way, the one way um, the main strategy to overcome it is to view for seeking help as a sign of strength and not weakness. And what about self-reliant perfectionists? They have assumption that they are genius, but yeah, they think that they know everything. But when they face something hard, they turn on self-sabotage because of their unrealistic expectations about themselves.
So it's essential to realize that making slow progress is still a progress. Understand that you will never know everything in your field and seek feedback from your mentor on your role expectations.
And there's one more type of people. They are experts. Um, Honestly, that's me. And and these people think they people think they are first when they don't know something, and they start procrastinating till they learn everything to start this work, because they think when they start learn everything they will know everything, and then they are worth to do this job.
And the solution here is obvious. Just learn only what you need when you need it.
Yep. In conclusion, sorry. In conclusion, imposter syndrome is the thing that many of us can face, but it doesn't define us. It's possible to overcome it, but it's important to say that if you can't control your imposter syndrome but by yourself, you should take care of yourself and consult a psychologist. It's not a sign of weakness, it's a sign of strength. Yeah, and remember, you belong here. Your skills are valid. Your voice matters. Let's build a community that supports and uplifts each other. Thank you.
Thank you very much. Okay, Yulia is the next one. Yulia is the next one. You put this on. Yeah, girls. I like the way when I went on the stage, how Alina did, like, go. It was, well, sort of like a sign, like I don't belong to this talk. Maybe I don't. I think I do deserve success. I am imposter. I do deserve success, but I was questioning, where is my yacht? Where is my stuff? But then I see this meetup and I think, this is success. This is maybe cooler than a yacht. So I'm happy about this. You have to be creative, you know. This is, yeah. Yulia, this is a part of the job. You see, this is, you have to manage. Or are you imposter on this stage? No. I heard this talk from Yulia on PyCon Czech Republic, and people liked it. So
now it's second time.
can we hear you?
Can we hear me?
Yes. Now.
Hello. Okay.
I mean, it looks good anyway. So let it be like this, please.
Now everyone hear me. Great.
Applause for Yulia, please.
Oh. Yeah, okay. So.
Okay, it seems like I need to put more jokes, which is getting difficult towards the end of the evening. So I need this.
We can do exercises. We can
Present,
applause. We
share
can
screen.
yell. Oh, yeah. Nice.
Okay, back.
Okay. So
Better?
let's start.
We need a blessing from Eugene. Yes.
So our talk will be Alexa. And before going to the talk, I want to introduce myself. I'm Yulia Barabash, and I am cloud engineer that likes to work with the cloud, that likes to work with different libraries, and also that likes to go different tech events. But sometimes it's very hard to keep track of all events and what's going on, like Python conferences, meetups, and so on. But maybe there's some stuff at home that can help us. For example, we can ask Alexa, because Alexa is nice tools. For example, you can ask what's the weather today. You can also ask to set up alarm for 7 a.m. Also set up timer, even tell a joke. She has very nice of humor. If you have bad mood, you just can ask her, tell me a joke, and you will feel better. But how we can give her additional skills? So with Alexa, there's also possibility to teach her some new stuff. For example, I don't know, maybe you want to deploy your environment from Alexa. Tell, okay, deploy to production, and it can give you. It can be very nice. I want to do this one day, but my boss doesn't like idea, so. But how it's possible to do? So basically, it's possible to do with AWS Lambda. So basically how it works is that you tell Alexa, okay, Alexa, help me. Alexa, translate all your requests into intents. And after that, these intents sent to AWS Lambda. And AWS Lambda will send you response, also do some functionalities that you can put, and send answer to you, and you will hear the answer. Now let's go to the demo. Before going to the demo, I want to show you a setup here, developer console, where you can develop your Alexa. For this, you need to skills define invocation. In our case, it would be Python help. After that, you need to define different intents. For example, we have standard intents, and here we have intent for tech event and conferences. We want to hear when the next tech event and conference. Great. And also we need to define our AWS Lambda. Here, I hope you see that, for example, one of the examples that we have our handler for conferences, where basically we use decorator, where we put the name of the intent. In here, we put simple functionality. Okay, just return this like phrase and answer user. So let's go to the demo part. And let's type Python help to invoke our Alexa. Oh, we have some. Wait.
Hi, PyMunich and PyLadies. I'm here to help Pythonists.
Okay, nice. Okay. And now let's type when is the next conference. Now I need to check my spelling.
Next Python conference is on PyConda and PyData Berlin 2024 on from 22 April through 24th of April 2024.
Great. And for example, usually it understands your speech as well, but for this demo, we just use typing because my laptop right now it will be hard to recognize. And for example, we can just ask when is the next tech event. And you also will get your answer.
Next Python meetup is Munich Data Geeks November edition on November 30th.
Yeah, and with simple functionality, you can build a bot. That's all from my side.
Bravissimo! Can you tune that script so that our meetups get a bit,
For sure.
higher?
Next
Okay,
time.
Very good.
Yeah,
I mean, data gigs are great. Highly recommended. We are friends, but a bit of your friendly gesture.
Yes.
Okay, good.
Next time.
Big thanks to Yulia. And next one is Vlad, the Python monster from London.
For Tech 5 with Anton. Thank you. Working as a cloud architect for Tech 5. This is my second appearance on PyMunich. I was here in August with another talk. So today I'm talking a bit more architecture and a bit more Python code. So once we have the slides, I really liked it back in August, so I decided to come again, and I'm looking for more events. This is a great event, thanks to Anton. And I think we said thank you to Jania, to our DJ. We said thanks to our speakers, but we didn't yet thank Anton as the organizer. Please.
Oh, thank you so much. You are cooler than the yacht, I told you.
So I've been to some Python events, but I think this is the best. This is like the best energy, the best fun, and the best organization. Thank you. Okay, here we go. So I promised to talk a bit about architecture, and we are talking about hexagonal architecture. So what it is, it's nice and it has 6 sides. Oh my God, why? Why do we need this? Like, we have so many other patterns in architecture and approaches. So the idea here is that it's a good pattern that can help in some ways to organize when you have external dependencies and you have different inputs. So it allows you to split them and keep your core logic in a good place. So let me talk about each part. So the core of the application is its business logic. This is where you want to focus. And you don't want to mix this with database access or some API calls, etc. And this is how you do it. You separate ports, and ports are these connectors where you need to connect to database, you need to send an email or text message, etc. Adapters are things that plug into ports and they do the job. So you can store data in database or message queue. It can be Postgres or it can be MySQL, and you may need to have different adapters depending on what database you're using right now. So this is what this architecture allows you to do. Code. Okay, we want to look, how does this translate to your code? So the control is the main piece. This is where you implement your business logic. Here it's very simple. If you say do create, then things are created, the email is sent, okay? Then the actual job of doing the stuff is delegated to the port. The port is like your interface. You just, in the port, you declare, okay, I have functionality of creating email, connecting to database, storing something in the database, etc. So the port doesn't have any implementation. The implementation comes from an adapter. And this adapter uses, for example, SMTP email client to send. Another adapter can use Amazon messaging for emails, etc. So you can have as many adapters as there are different systems that you can use. They all implement the same interface, but with different clients, with different methods to do the job. And you can swap them depending on your need. Now, you change the adapters, but your logic stays the same, your controller is the same, and your port is the same. So those are the parts that don't change. The great thing about this architecture, it helps you test your code. It makes it easier. Let's see how it's done. So this is the control we saw before. This is the part that you really want to test, because this is your business logic. How do you write the test? Okay, so we do the mock of our ports, and you remember that ports is something that connects you to external systems. And now it's all really easy. So you abstract away all those external dependencies. And now you can focus on just the business logic that you have in your application, right? So you can say, oh, this is how my data should look like. And I want to verify that whatever is coming back is what I expect, so that my logic functions correctly. So remember, separate your business logic from lower level abstractions like database connections, APIs, etc. Okay. Now, how do you approach the building the architecture? I mentioned this a couple times. The business logic is the most important part. So the core of your application. So you need to understand. And from my experience, it is hard. I often find myself writing a lot of logic in the adapter. The other day I thought like, oh my God, why my adapter is so complicated? How do I make sure that the business logic doesn't go there? And then the way to approach this is you try to think, if I replace this adapter for Microsoft SQL database with Postgres, do I need to copy this logic there? Oh yes, then it means it's a business logic really. It belongs in the control, in the upper level. Because in the adapter, you only write the part that's specific to this database or this API that you want to plug, right? Because it's the adapter. Now, we said that adapters are for different things. So I can have a message queue adapter, I can have a database adapter, email adapter, SMS adapter, and so on. The ports are just interfaces. So these are abstract things that you need from your adapter. And what I like about this architecture, it forces you to do your unit testing right. So you can focus on the business logic and write the test for it. You don't need to test your database. Okay? So mentioned testability is the big one. Now, you can easily swap parts. So if you think that your application will need to support different backends in the future, this will help you swap. And it helps you to structure in such a way that it's modular, so you don't mix everything together. So it's easy to separate the core business logic from, those plumbing below. Okay, it's not easy. As with design patterns, this is big. This is like how you structure your whole application. So you kind of learn how to do it right. It requires some investment, and you need to be careful with your dependencies to make it right. But if you are building something bigger, that it really pays off in the end. So don't try to do too much. Do something small in the beginning, and work with others, because if you're building something complex, you sometimes don't really know where to draw these boundaries. So the input from your team can help. Okay, that's everything I have. That's how I learned to do hexagonal architectures, and I do recommend them. Thank you.
Thank you very much. Thank you very much. Do we have any spontaneous speakers? Be brave. Come on, it's a good time. No. Okay, that's good. Then we come to the do we? If you can sing a song, that also qualifies as maybe Merry Christmas, some jingle bells. I don't know. No, not today. Good. Then we come to the final time, and this is where we say thanks. And this is very important, because first, it's not just us, it's PyMunich plus PyLadies. So I would like PyLadies organizers here. Olga, you as well, please. And we need to say a special thanks to them. Because to be honest, like there were times when I'm so lazy, but Lisa is really like pushing hard. Anton, we have to do it. We have to do it. We do it, and we actually did it. So yeah, big thank you to PyLadies. This is number one.
Thank you.
Thank you very much.
It's kind of cold outside, so I guess we wouldn't be meeting on the street. So Netlight is not only giving us the location and the possibility to do this, but also share their enthusiasm. Like they are actually very motivated to do this sort of events, as I feel. So I would invite Rafael as well here, please. And you are representative of Netlight, so okay, please. So thanks for hosting us. Then, as you noticed, except of the stupid jokes, I don't talk much about Python. So I would also invite all the speakers of today to come on the stage, because this is the content. Please. Yulia, Alina, all of you. That's great. Okay. And then finally, yeah, there is also a missing piece. Like we are a Meetup, but we are also a company. We are an agency. And this is something that stays behind the scenes, but it shouldn't. So I would ask all of our team members who do this to also come to the stage. And that's Eugen, that's Daniela. Where are you, Daniela? Here, please. And Eugen is still tuning the camera. Like he's so responsible. Like, Eugen, come. It doesn't matter anymore. It's okay. So please. Did we forget anybody from our team? No, we didn't. Everybody here, because it's a lot of overlap. Like we are a company, we are a community, we are speakers as well, organizers as well. So yeah, everybody paid their piece, and it's not even my ideas for the most part. Like you saw these chocolate bars. Like Daniela is 3 weeks with us, and that was fully her idea. By the way, I have to speak about those chocolates. They are, of course, promotional chocolates. And it's talking about us, about our company, because we do this stuff of meetups. It's our like free time, it's our passion. But we also work. We are Python developers. So we are very active in Munich. So if you have a project where you need help, please remember the good ones, the ones who pay back to the community, and hit us up. Apart from that, I cannot invite really all of you to the stage, because this is, yeah, even with the Netlight, I think it would maybe crash. I really like eating a lot before Christmas, so maybe it's not just me. But yeah, again, we would not do it for the empty room, obviously. So it's always good, and we have this emotional connection to the audience, I think. So I would say then now a big thank you into that direction. Now we applause to them. Let's do that. Okay, now we have a challenge. We have something like 20 minutes to finish all the beer of Netlight. You think we can do that? Yeah? Okay, then let's take a challenge. Thank you very much. Beautiful. Beautiful.